Hey everybody, and welcome to the demo of the VM service in Tanzu Services with vSphere 7. What you can see on the left side is my vCenter with one data center and one Kubernetes cluster, or my supervisor cluster with 4 ESXi hosts and a couple of namespaces that I've already created. On the left side, you will see the console already connected to my supervisor cluster in that context, so I can interact with kubectl API. And the first thing is going over the new namespace service. So if you will go to the Kubernetes cluster on the cluster level, configure in the namespace section, in the general, you have a new namespace service tab. And when you're allowing that namespace service, you're basically allowing your DevOps engineer to create namespaces in the supervisor cluster through the kubectl API. Now, to do that, you have to configure a resource limit, because when the DevOps will create that namespace, you want to have that guardrails of resources from CPU, memory, and storage perspective. And you also indicate the user that can create those namespaces when authenticating to the kubectl API of the supervisor cluster. So in this case, I've enabled the administrator to create a namespace with the different configuration of CPU, memory, and storage. So if I will do kubectl, create namespace, let's say test, I'm creating a vSphere namespace through that kubectl API. And if I'm hovering above that namespace, you can see it's already configured with the resource limits of the service itself. So each and every one of the namespaces that will be created with kubectl API will basically automatically will get that quota policies according to the service configuration. Now, let's go to the VM service section. You can see a new tile in that namespace, VM service tile. And in here, you can configure the two foundational configuration that you need to basically enable the VM service itself. And to be able to provision a VM through kubectl API with kubectl contexts, you need to configure a VM class, so basically the size of the VM that will be provisioned, and you have to configure a content library which facilitates every OVA and OVF file of those VMs that will be managed by the Kubernetes API. Now, another thing you have in the new version of vSphere is you can also create your own VM class. So when I'm clicking on Add VM Class, I'm basically bonding a VM class into a specific namespace. In this case, it's the test namespace that we've just created. And you can see a lot of different classes that is pre-configured. But if you want to create your own, you can click on Create New VM Class, and then you will be redirected to the VM Services page, configuration page, where you can actually add a new VM class. Just stating what's the name, let's say test class 1, how many vCPUs, how many resource reservation if you want to configure resource reservation, and how much memory, of course megabytes or gigabytes. Let's do 10 because I already have one. If I will do create, it will just add that a new test class to my to the others VM classes, and I can just bond that into the namespace. So if I will go back to the namespace itself and going back to the tile, now I can click on Add VM Class and just choose, let's say, the test class or the test class 10 that we've just created. In this case, I'm gonna add the best effort extra small, because I'm gonna use that in the YAML file for my VM later. Second thing is the content library. Just like we have in terms of Kubernetes Grid, a content library that basically facilitates all the OVA files for the Kubernetes clusters, I've created another content library that basically has all the OVA files that I can use for the VM service. In the first version of the VM service, you will be able to provision either an Ubuntu machine or a CentOS machine. They will be published in the Solution Exchange and you can download them and just add them manually into your content library. Now, that content library, again, should be bound into the namespace itself. So if I will go back to the namespace of test, add content library, and now I can choose the VM service that has 4 different OVA files. Okay, and now I'm ready as the VI admin to basically expose that environment to my DevOps engineer and to provision a VM into that environment. I've configured the VM class, I've configured the content library, there's a quota limitations, so I have my guardrails, and the administrator is configured as owner. Exactly the same, you can create a different owner from your SSO domain, and the owner can create those namespaces. So basically, I've assigned an owner permission to that namespace of test. Now, next thing is create a VM. And in this case, we're gonna first create the VM and then see what's the building part for that. So I'm just gonna do kube control create, just like anything else. I'm lazy, so I'm gonna use K. So create -f and VM, let's say Ubuntu in this case. And I'm gonna deploy that into the VM service namespace, not the test one. And you can see it's created for me 3 different objects: the virtual machine, the config map, and the virtual machine service. Those are 3 different objects that I've declared in my YAML file to basically create that VM. Now you can already see that there's a deploy OVF task that is being created. So the VM is being created right now. If I will hover above that VM service, I will see that it has the VM classes and the content library. And if I will go to the compute, inside the VM resources virtual machines, I will see my VM service Ubuntu 01. If I would have TKG clusters, or one or many, I would see that in the Tanzu Kubernetes cluster, and the virtual machines for those different clusters would have been here alongside the new VM service Ubuntu 01. Now, from the configuration side, to see that everything is working fine with that VM, I can just hover above the VM itself on the vCenter, and I can go to monitor and see events that is basically going on right now in that post-configuration, pre-configuration, what's going on inside that process, and we will go over that. And I can also go and see the configuration VApp options and basically see the configuration for that machine. Here I can see different post-configuration that I've created, including the cloud init post configuration that we will go over in a couple of minutes. Now, in this case, it's going to take a little bit more time. So what we're going to do now is we're going to go over the YAML file for that virtual machine, or the object for that virtual machine. So I will go to my virtual code, and I have here the YAML file that basically I've created the virtual machine from. And you can see the first section is basically declaring a virtual machine kind. And I'm labeling that with a label because eventually I'm going to use that for the network service later on. So my selector Ubuntu services, that's the name of the VM, and then network interfaces. I'm using NSX, and you can see that here as well. So basically the VM is being connected to the same logical switch that is part of the same tier 1 for that namespace. It's the same networking structure for Kubernetes. And that's part of the advantage where you're using different parts of the application in different kinds of objects like VM, native pods, or maybe a Kubernetes cluster. Everything will be connected to the same tier 1 router. And then you can use the Kubernetes structure to basically decide about security or other things. So in my case, my network interface is NSX. The class name is best effort extra small. And that's exactly what we've configured when we bond that namespace into a specific VM class. And the image name is Ubuntu, so that's the one that I'm pulling from my content library. It will be powered on automatically, and you can see it's already powered on. And the storage class will indicate where the data store will be. So basically based on that storage class, it will be the specific data store. And then you can see I'm configuring a Vm Metadata. And what I'm actually configuring here is I'm configuring a config map that is going to be injected as an OVF environment. And that config map has a cloud init postscript in one single line, which is basically a base 64 for a YAML file. Now, let's double click on that config map because that's basically all the post configuration for that VM. So the first thing will provision a VM, but it's going to be a clean one without any configuration, just the OVF being deployed to the vCenter. And the config map and the cloud init parts is basically what's post configuring that according to whatever I need. So if I will switch to my cloud config YAML file, that's the YAML file that I've basically printed in base 64, and it's being integrated inside the config map. So that's the single line that you see over there. And let's go over the configuration. So basically I'm configuring a username, a password. Of course, I changed that. It's not admin, but a password within a hash kind. You can see I'm writing files to the VM itself. So basically just saying hello world in a specific path. I'm installing with apt the Docker environment. So I'm basically installing Docker on that Ubuntu machine after the creation of that. I'm installing Docker CE and Docker CE CLI. And then I'm running one single command line that basically runs Nginx as a Docker container, exposing port 80 from that container on that VM. So I know it's kind of weird, like why should I run container inside a VM and then expose that? But it's just an easy example to show, and it's inside of that cloud init YAML file, you can see different aspects of the post configuration. So writing a file, installing a package, and then running a command, basically exposing that Nginx. So when you want to basically print out that file, the only thing you need to do is to, let's say, cut that YAML file in base 64. That will print out one single line that basically is this line inside that config map. So once the VM is being provisioned, it's using that config map and the postscript to basically post-configure the VM. Now I want to expose that VM, so I'm creating a virtual machine service, and that virtual machine service will expose the VM according to the label, so according to Ubuntu services labels, and it's going to expose port 22 for SSH and port 80 for web. So if we will check that VM right now, and we will check the service IP, which is a load balancer service. So NSX exposed that with a load balancer IP. And I would be able to SSH that VM, and I will be able to browse that VM because as a reminder, inside of that cloud init configuration, we've basically running an Nginx container on that Docker platform. So let's see what's going on in the Kubernetes side. If I will get VM in the namespace VM service, I can see my VM. If I will get SVC in the VM service, I will see the service Ubuntu services, and I can see an external IP. Now, the first thing is to SSH to that VMware at. That's the IP. Yes. And that's the password. And I'm inside a container. So if I will do a Docker PS, I can see Docker is installed, and I can see it's pulled my harbor.tanzuworld opens on Nginx, and it's exposing that in port 80, which means that if I will browse that IP, I will also get to that Nginx inside that VM. And that means that the entire process of the post configuration with the cloud init worked fine, and everything is working according to whatever I initially configured. So now we can exit that and exit that VM, going back into my Kubernetes cluster. Another thing that I want to show you in this aspect is when I've configured the VM services, VM classes and content library, we did that as the VI admin in the vCenter side. Of course, you can see that in the Kubernetes side as well. When I'm indicating a specific image or when I'm indicating a specific VM class, it's also part of the Kubernetes objects, and you can see that in Kubernetes. So if I will get a virtual machine classes, you're basically going to see all the classes. But if I want to see what is bound into the VM service namespace, I need to add the virtual machine class bindings, and then in the namespace VM service, I will see which are the ones that is connected to the VM service and I can use. Same goes for content library, or in the Kubernetes side, content source. Content source. Content source. So content source basically going to show you all the different content libraries that you have. In this case, if I will do the binding and I will add a VM service, you will see exactly the same because I have two. One is for Tanzu Kubernetes Grid, which is enabled on that namespace, and the second is for the VM service, which is enabled on that service. So as you can see, everything is also a Kubernetes object where you can see that, declare that, check that, and everything else. So that was our first part of the demo, basically creating a VM and creating a namespace with a namespace service. Now, what I want to do now is I want to automate everything, because eventually we can use that Kubernetes API to automate everything, including creating that namespace, patching that namespace with configuration like the VM clusters and the content library that we need, and then create different VMs according to whatever I need, and exposing that everything that we did right now manually can be addressed automatically, because that's part of the power of Kubernetes and that's part of the power of automation in Kubernetes. So what I've created is a simple automation script that basically does exactly that. It's logging into the vSphere supervisor cluster. It's creating a namespace with the name automation, and then it's basically patching that namespace with an API call to the vCenter, stating who's the owner of that, so administrator, and what's the VM class that should be used, and that's the best effort extra small, what's the content library that should be used, and basically after patching that with that API call, I'm just creating the VM Ubuntu Nginx YAML file. Now the VM Ubuntu Nginx YAML file is a little bit more complex than what you saw in a single VM. So basically I'm creating two different VMs because I want to have a load balancer that basically load balance between two different VMs. Both of them will do exactly the same. Both of them will have exactly the same config map, and both of them will be exposed with exactly the same service. So going over the automation script, I'm creating a namespace, I'm patching the namespace with configuration, and then I'm just deploying that YAML file. So if I will run that, okay. So it's logging in, it's creating the namespace, patching the namespace, and you can already see the namespace is being created. It's adding the test class and machine class, and then it's deploying the Ubuntu machines. That's the virtual machine 1, virtual machine 2, config map, and virtual service. If I will go to automation and I will over above that, you will see that the VM class that is configured is the best effort extra small, just like we've configured in automation. That's the content library. And if I will go to compute and the virtual machines, you will see two different virtual machines already being created. So in the meantime, when that's happening, I want to show you the third part of the demo, and that's where we can actually use that VM service capabilities as part of a real life scenario, right? And in my case, I have my Acme Fitness app running inside a namespace, and you can see that's the Acme Fitness app, that's the catalog, and everything is working fine. It's a little bit slow because I'm injecting traffic to that application, but basically the Acme Fitness app is has a polyglot architecture where you have different parts, bits and pieces, front ends, back ends, and different cache layers and databases. And what I did with that application is basically enhance all the power of the supervisor cluster in different aspects. What you can see inside the Acme app, and if I will go to compute, that will be the best place to start with. You can see vSphere pods. So I'm running Redis and Mongo as native pods directly on the supervisor cluster. And that's just to harness the power of the supervisor performance and isolation capabilities, so security and performance. But from the other end, I have also a virtual machine that has the orders of the Mongo as a virtual machine. So we can see cuts Redis, catalog Mongo, orders Mongo, and users Mongo, but the orders Mongo is a virtual machine that runs the Mongo as part of the Ubuntu OS. And the front end of the application is running on a TKG cluster that is a different Kubernetes cluster running in the same namespace. Now, why it's powerful? It's powerful because all of the different components is being connected to the same logical switch and the same tier 1 router inside the NSX. So if I will go to the network topology and I will look for that Acme app, and let's get in a bit, and so that's the Acme app, and you can see the Acme namespace inside the tier 1 router, and you can see 3 different logical switches. In one, you will see the pods, so basically the native pods running all the different backend services for the pods. In the next one, you will see the VM service, so that's the Mongo of the orders. And then you have another logical switch for the TKG cluster, for the Tanzu Kubernetes Grid cluster. That kind of visibility and possibility of implementing security measures inside the networking stack and distributed firewall rules, root cause analysis in case of something went wrong, that's really powerful. And it's, again, addressing everything as a single, in a single API with the power of Kubernetes behind everything. So I can create that application with a single YAML file that basically going to deploy that TKG, the native pods, and the orders Mongo as part of that. To create that orders Mongo, by the way, I've created the same process you saw in the Nginx, but basically I've installed the Mongo inside that Ubuntu, and I've post-configured the Mongo according to whatever I needed from username and password, so everything will be connecting together. So that's just a real use case from an application running on different objects. As far as I can see, the application in the automation is already finished. So let's see if it's running fine. I will again get service in the automation namespace. And if I will browse that, I should see again Nginx running. Not yet, so it's not up yet. Let's do SSH VMware at. Yes, okay, it's up. So it took a little bit longer. But now I'm SSHing to basically one of those VMs and Docker PS. Yep. So it's running. And if I will get, by the way, another important thing. So I've showed you the service, get service in the namespace automation. But if I will get endpoints, get endpoints in the namespace automation, you will see that there's 2 different, there's one. So the second VM is not ready yet. So the second VM will be up and running, and then you will see in the endpoints the second VM as well. It's basically being configured right now as we speak. Yeah, so I hope it was useful, and I know it is really powerful. As far as I can see and as far as I can predict, that's the way that we will address VMs in the future. So again, I hope it was good. I hope it was useful, and stay tuned for the next videos. Thank you very much, everybody.